What up, guys? Yay! Do you know what's the applications for transformers?
Back EMF.
Do you know what is the modification of transformer?
Do you know how the transformers work? We are here to tell you!
I've been there so long, they look like up to me. They look up to me. I got fake people showing fake love.
What is a transformer? Transformer is a static device that changes or alternating potential difference from one value to another using principle of electromagnetic induction.
A transformer consists of three main parts: the metallic core, the primary winding, which produces magnetic flux when it is connected to electrical source, and the secondary winding, which the flux produced by the primary winding will pass through the core and link with the secondary winding to give the desired output of the transformer.
When alternating current is allowed to flow through the winding, alternating flux will be produced surrounding the winding. Hence, we can say that magnitude of the flux is proportional to magnitude of the current through the winding. Alternating current produces continually alternating flux surrounding the winding. The flux lines link to the winding itself and is varying, so there will be a self-induced EMF. So this is according to Faraday's law, where rate of change of flux linkage with respect to time is directly proportional to induced EMF across the winding. Supposingly one separate winding is brought nearer to the first winding, the portion of second winding will get kinked to the first winding. Due to this varying flux linkage, there will also be an induced EMF across the second winding. However, this induced EMF is small. Because the flux linkage is small, hence the rate of change of flux linkage is also small. We can say that this is according to Faraday's law, where induced EMF is directly proportional to rate of change of flux linkage. To transfer maximum electric power from the primary winding to the secondary winding, we have to link maximum flux from the first winding to the second winding. This is done by placing a low reluctant magnetic core in between these windings. For example, steel. As long as we place the steel core in between this winding, the entire flux which was surrounding the first winding will be concentrated inside the core and linked with the second winding. As nearly the flux lines link with the second winding, now the rate of change of flux with respect to time is equal in both windings. If any closed circuit is connected to the secondary winding, we will provide voltage across the circuit, and due to the voltage, there will be current flowing through the circuit. If number of turns of both windings are different, the voltage will also be different. That is why there is step-up transformer and step-down transformer. Step-up transformer have more number of turns in the secondary winding, so it increases alternating voltage, and the step-down transformer have more number of turns in the primary winding, so it decreases the alternating voltage. Yeah, so that's all from me. Bye!
Hi guys, so today I'll be talking about back EMF, and it's a bit sunny over here. Back EMF, also known as the back electromotive force, also known as counter electromotive force, also known as CMF, or whatever you want to call it, as long as you're happy with it, is the force, or because it's induced, the EMF, that pushes against the current, which induces it. Putting it in a simpler way, you can imagine that back EMF is like the friction in the current. Now imagine that current is a marathon runner running in one direction, and then back EMF is like the wind acting opposing to the runner. Thus it slows down the runner. When there's a back EMF, the voltage of the circuit will drop. Okay, I know it sounds very complicated, so let me just illustrate it for you.
So now I'm drawing a sort of transformer. So this is a primary circuit connected to an AC power supply, and then there is the secondary circuit, and I'll put a switch and I'll leave it open. Because it's an AC power supply, the positive terminal can be here and the negative terminal can be here, and you can switch because it's an alternating current. You can switch and switch and switch, but let's just stop here and let's just allow the current to flow in a clockwise direction. I will draw an arrow or two indicating the direction of the current. This circuit is powered by an AC power supply Therefore, there's a supplied voltage in the same direction as the current. So it's going downwards, and I'll call that V app because supplied is too long. And oh yeah, I almost forgot. Before I go into further explanation, let me introduce you two very fine gentlemen, very famous physicists, and they are Michael Faraday and Emil Lenz. If you don't know them, you should be ashamed of yourself. Just kidding. Faraday's law of induction states that the induced EMF in any closed circuit is equal to the negative of the time rate of change of the magnetic flux enclosed by the circuit. This can be simplified to when there's a change in magnetic flux, there will be induced EMF. LOL! However, Lenz's law states that the direction of current induced in a conductor by a changing magnetic field due to it's too fast. Just remember that for Faraday, it's induction of EMF, and for Emil Lenz, it's opposite direction. So let's get back to my beautiful drawing over here. Like what Ming Hui said just now and how transformer generator works is that the current in the primary coil will produce magnetic flux that goes through the secondary coil, and therefore there will be induced EMF in the secondary circuit. But in this case, the secondary circuit is open, therefore there will be no current. Now here's the thing. The magnetic flux from the primary coil will go through both the secondary coil and the primary coil itself. And according to Faraday's law, there will be induced EMF, and according to Lenz's law, the direction of this induced EMF will be the opposite direction of the voltage applied. This induced EMF is called the back EMF. So now we can form a simple equation, which is V net is equals to V app, which is the voltage applied, minus V back, which is the back EMF. And for your information, this V net is very, very small. So what I'm gonna do now is that I'm gonna close the switch in circuit 2. That means the circuit will be closed, and there will be induced EMF, and there will be current. So is that a problem here? Yup. And if you didn't notice it, that means you're not paying enough attention. Remember what I said about Lenz's law? Opposite direction. The direction of current in circuit 2 should be opposite of the direction of current in circuit 1. So the arrow should be like this. And because there's current now in circuit 2, there will be magnetic flux from the secondary coil, and it will go through the primary coil. And therefore there will be induced EMF in the primary circuit. And the direction of this EMF is actually opposite of the direction of current in circuit 2, which is the same direction as the V app. And this EMF is actually the back EMF from circuit 2. So now we can edit the equation to V app minus V back plus V back 2, which is the back EMF from circuit 2. So the net voltage is not very small anymore. Yay! So that's pretty much it. A brief idea about back EMF, specifically in transformer. I hope you really understand and try to simplify everything for you. And now let's move on to the next topic, which will be presented by Mr. Pravin. Apparently he's stuck in an elevator. I'm just gonna think of a way to save him.
Hey guys, today I'll be talking about application of transformers. Kapow! Transformers are used to increase or step up voltage before transmitting it into long distances through wires. Well guys, wires have resistance, which loses energy through Joule heating at the rate corresponding to the square of the current. By transforming power to a higher voltage, transformers enable economical transmission of power distribution. Consequently, transformers have shaped the electricity supply industry, permitting generations to be located remotely from points of demand. Since the high voltages carried in the wires are significantly greater than is what needed in home, transformers are also used extensively in electronic products. to decrease or step down the supply voltage to a level suitable for the low voltage circuits they contain. Well, the transformers also electrically isolates the end user from contact with the supply voltage. Signal and audio transformers are used to couple stages of amplifiers and to match devices such as microphones and record players to the input of the amplifier. Well, audio transformers allow telephone circuits to carry on two-way conversation over a single pair of wires. Well, a balloon, as they say, that's how they pronounce it, I guess. Well, transformer converts a signal that is referenced to ground to a signal that is balanced voltage to the ground, such as between external cables and internal circuits. Well, transformers made the medical grade standards isolate the users from the direct current. These are found commonly used in conjunction with hospital beds, dentist chairs, and other medical equipment. That's all from me today, guys. I'll see you in soon.
Hi, today I'm going to be talking about the modification of transformer. There's a lot of issue in transformer. The first is the resistance of the winding. We use the low resistance of wire for winding, but still got a lot of resistance to contribute the heat loss. The second issue is the flux linkage. The flux produced by the first coil may not all transfer to the second coil if the design of the coil is bad. The next is eddy current. The changing magnetic field is not only inducts current in the second coil, but also current in the iron core. The current that flow in the iron core are eddy current. The eddy current causes a lot of heat loss. And another issue is hysteresis. The repeating core magnetization of the core is repeated preserved by the alternating magnetic field. This process expends energy and this appears as heat.
How to solve all these issues? People build three-phase transformers to solve all these issues. To build a three-phase transformer, we start from the insulated frame. Laminated and well-insulated iron core are used for the completion of the magnetic circuit and to reduce the eddy current losses. By reducing the eddy current loss, we can reduce the electrical energy to being wasted as unwanted heat energy. Insulated sheets are used between the high voltage and the low voltage winding to prevent a short circuit. The tank protects all the winding and the core from the atmospheric effects. The conservator with oil level indicator are used as the oil storage tank, and it is mounted on the top of the transformer. A breather is used to prevent the transformer oil from the atmospheric pressure. The cross relay is installed in oil immersed transformer for protection against all kinds of faults. The high and low voltage bushing provide proper insulation between live conductor and earth to tank. Explosion vent provide an exit path to the gas produced in the transformers. The radiators are used for the transformer cooling purpose. A thermometer which is mounted on the transformer to measure the temperature to protect the temperature going too high or too low. Drain valve is used to drain oil from the transformers. Oil is used for cooling purpose. The oil used should not have the flash point less than 160 degrees Celsius. Oil is an organic compound. It produces various degradation products. Most dangerous are acid, peroxide, and water. Deposits and slugs form on the surface of transformer winding. These reduce the heat transfer capability and also the cooling capability of the oil. Decomposition of the product also attacks the insulated sheet between the transformer winding, and the insulated sheet will lose its dielectric properties. These are some ways to prevent the oil from decaying. First is to switch off the transformer and change the oil. But during the oil are changing, slots and deposits are still remain in the transformer. When the new oil are filled in, the oil impurified immediately. A better result can be achieved by regenerating the oil during transformer operation. The new oil are pumped in and the impure oil are removed at the same time. After that, the impure oil are transferred to another machine. This machine cleans the oil and ready for reuse. All process and data are monitored. This way are more environment friendly than the previous way.
तेरे रोमे गिट्टी ले जे बुल करके जे मित्रा ने होर पट ली ओ तेरे रोमे गिट्टी ले जे बुल करके जे मित्रा ने होर पट ली बिल्लो बाली ना तू बन रुखी साडे दोवां चों होना बस तू ही दुखी गरम मूड चे मैं होर सेकना नहीं ते जद तुर पिया मुड़ वेखना नहीं सोनी नूकी गाना जे सबा तेरा चंगा नहीं लुकी होण नालों फिर तां कल्ला ही मैं चंगा सी